Okay, hi everyone, and thanks a lot for coming. Yeah, maybe you are thinking that this is the most depressing and boring title in the world, right? And yeah, you are right. But I believe it's worth it because the lessons come, they are authentic. They really come from the trenches, so from real situations, from real pains, real human beings. So let's save some minutes. If someone wants to know more about me or about what I do or why I do it, you can go to this URL. And let's start. Let's set the stage, right? I work in my day-to-day work as a developer in this Vue SaaS software as a service application with more than 2,000 Vue components, so it's a pretty considerable size, plus 50 features, and this keeps growing. More or less 3,000 JavaScript and TypeScript files. And right now, we are more than 100 front-end developers working every day in the same code base. So it has some big challenges here. So what I mean with this is that these lessons come from real production pain, so from real situations, real frictions. They are not made up in a laboratory just to fit the talk. Everything is real, so this kind of real pain, right? The one that makes you burn the whole system sometimes because it gets under your skin. You can see it coming again and again. So let's start. And I'm going to start with the most painful to me, especially, right? Because we were so close, so absolutely close, but in the end, it couldn't happen. And it was the Vue 3 migration. Yeah, you can imagine, right, what happened. So let me share some details. We organized a compact week, right? Because we had the compact version, very nice documentation, the path was already laid out, and we were so close. So we were just grasping with the end result. But it couldn't work. Why? So it was nothing technical related, to be honest. It was the human factor. And you will see this pattern come over and over again. So you will see the effects rippling, the technical part, but you will start, I hope, you will start thinking, if this is only technical or this is something else, right? So again, we organized this compact week, migration, alongside ongoing development. So it doesn't make any sense, but at that point, I don't know why, it was a super nice idea, and everyone was on board. So the result was a massive pull request that is extremely complex to merge. So in the end, we couldn't migrate. So the pains, right? Concurrent development equals constant rebasing. Can you imagine that we had 10, 15 people, if I remember correctly, super talented people, I have to say. That's why it's so sad to me. Trying to migrate the whole, the most painful dependencies, also the major Vue version, following the guidelines, but also the rest of the company was pushing code and pushing code. So we were doing revoices from hell every night, but in the end, it was extremely complex, so we couldn't keep the pace, right, with the company. And also, this is important, it was a voluntary side project. So we were dealing with our own sprint task, every developer, the ones that we were participating in this effort, and also the migration in our extra hours, so to speak. But again, the key part here is that the rest of the company was acting like nothing is happening, right? So the lessons, and this is very painful. Never, ever migrate your major front-end framework version during active development. And again, this is silly even to say it, right? But I don't know why I don't know what we were thinking at that point, but we tried. And the sad thing again is that we were extremely close. We were extremely close. We were passing tests, we were seeing the SaaS functioning with this new version, but it didn't work. So never ever migrate during active development. And also, this kind of efforts should be treated like an official thing, right? So every stakeholder, every project manager, everyone in the company needs to know that things are going to slow down a bit. And you have to pay in advance, because you have to pay no matter what, right? You can pay now with your own terms, without interest, or you can pay later. And it's a lot more painful, right? So it has to be understood and knowledge, right? And the end result is this, is the monster pull request. So you cannot see, but it's close to 1,000 files. And it's like a monolith to our, I don't know, I won't say it was a failure because we learned a lot of things. I personally learned a lot of things, but it couldn't work. You can see that Vue router was migrated, all the other dependencies were migrated, but in the end, yeah, you cannot control this, right? So this was the most painful to me. Well, let's move on. We have trans-feature communication because, again, remember, we have more than 50 features, and this number keeps growing. So sometimes we have to communicate the features, and we have a very clean architecture, but there are occasions, not anymore, I believe, but there are occasions, we spotted this red flag in a couple of times, to be honest, that some features were contacting between each other. And again, why a developer creates coupling? Because the pains are that imperative cross-feature calls, type coupling, and inconsistent event handling patterns. So the first one, why a developer suddenly connects one feature with another imperatively? I don't believe this because the developer is lazy or is a bad human being. I believe that there is another factor, right? And the people are being pushed to reach production as soon as possible. So some KPI, some OIT, some deadline, and what starts innocent enough suddenly becomes completely out of hand because we are 100 developers working on this code base. So imperative cross-feature calls, tight coupling, a feature with another. I will show you a snippet in one second. And also inconsistent event handling. And this seems like a silly thing, right? Because it's an event, and everyone here knows what an event is, but everyone here will write an event handler differently. So if it's a solo project, amazing, no problem at all. But if we are 100 plus front-end developers creating events, again, this becomes out of hand. So what with this, or the lessons of this specific point, is that we should use declarative event patterns. And I mean the event emitter pattern from Node.js. You don't have to reinvent the wheel. There's nothing groundbreaking here, right? And also create factory functions for consistent event handling. So let me show you. The first snippet is the imperative call. And why? Why does this happen? So let's imagine, right? We have feature A and feature B, and suddenly you want to connect feature A with feature B. So the user clicks on feature A and lands on feature B, and you want to notify feature A about what the user is doing in feature B. So what do? You import the service from feature A and call feature A from feature B. And again, this seems innocent enough. It's just once, just for this time. We will refactor in the next sprint, and this next sprint has another things to do. And this keeps in the backlog Jira that no one checks it anymore. But you are connecting the feature, you are making it interdependent, difficult to test, and we have a clean architecture just to avoid these kind of things, right? So again, why a developer does this? I don't believe probably, well, it could be that it's lazy, I don't know, but probably the developer is being pushed to reach production as soon as possible. So the stakeholder, the project manager is lurking around, and in the end, you do these kind of mistakes. So the lessons, declarative event patterns and factory functions. So what do I mean? We can use a factory function. Well, first of all, let's imagine a calendar, right? We have a calendar, and the calendar, what kind of events, declarative events close to the business logic, close to the domain can event. So appointment created, appointment rescheduled, appointment deleted, and you can even send some metadata about the event as a payload. And this for me is, okay, loose coupling, maybe, I don't know. But it perfectly ties the scope of the feature. So if I'm a calendar, when something happens inside my feature, I'm just emitting an event. And if someone wants to listen, perfect. And if someone doesn't want to listen, perfect also. And for the normalization of the events, we use factory functions. So as you can see, we have a simple on price, in this case, price sell saves, is the creation of the event. Then we are going to removing the listener with off price and then emitting. And this is super easy to implement and solves a lot of problems, specifically this trans-feature communication. I hope this is clear. So let's move on. Global state, and this is a super tricky one. Because plus 50 Vuex mod. Who here has worked with Vuex? I'm super sorry, to be honest. Well, we have a massive Vuex store, and what started as a clean architecture with modules, etc., because it always starts nice, right? But in the end, it goes to hell. So clean architecture, gradually developed into tight coupling, again, over reactivity. This is a hidden danger, and we do compromise, right? We cut corners, cheat the process, etc. So what do I mean specifically? Cross-module dependencies, tight coupling, and over-reactivity, and direct state access. So why a developer? Well, thinking about Vuex, if you factor a massive Vuex store with TypeScript and with modules, just to reach a piece of state, you will probably have to modify 5 files, 6 files, 7 files. So I can understand how verbose Vuex is, right? But if you are crossing the boundaries between features in your Vuex store, is the same as the feature, that example before. You are doing it because someone probably is pressing you, or you have some not artificial, but some deadline to meet. So you cut corners, you cheat, and then you end up in this mess. I will show you in a second. So first, the lessons. Keep component state as local as you can, because we found that this was like a rule of thumb that this wasn't written anywhere, is that every piece of state belongs in Vuex, and doesn't make any sense, right? So we suspect we have a lot of state that are not being used anymore, that was shared before, but for whatever reason isn't shared anymore, and it's still there, right? So keep component state as local as you can, and also, maybe this piece of state only belongs to the component, but if it's only shared between 2 or 3 or 4 components, maybe it's not worth to be in Vuex. You have composables now. You can use reactivity APIs outside components just for this, right? You can create a composable just to share this state between n components inside the feature. So let me show some examples. This is the cross-module dependency that creates tight coupling. So suddenly are referring specifically from one module to another, creating the full path, etc. And this is real code, by the way. Everything here is real code, absolutely. So it's online payment enabled, and you start writing the whole path, etc. So this is difficult to test. It knows a lot. Depends on this structure. So when you change it, so you will find some nasty errors, right? And the overreactivity, and this is not so obvious. If you put one of these sentences into a computed property, every time the state or invoices or selected invoices change, you will reevaluate, right? So this is also a hidden danger. Right? We will talk about performance in a moment, but this is also belongs to performance. So the lessons: component state as local as you can. So really and carefully decide if this piece of state belongs to the component, to 2 or 3 components, a composable, or if it really needs to be in Vuex or not, right? Because if not, everything goes to Vuex. And use composables just for this, for cross-component state. So what do we have here? We have a composable called use user settings, and it's using the getters, the actions, dispatching actions or mutations. So I'm only interested in the contract. I'm only interested in the contract. So I don't care about how we get this stored. You can change we are only interested in the interface. It's the last line that is not highlighted, the one that is here. And I don't care about the contract. In fact, you can change to another store, and the signature, the interface will be exactly the same, right? But if you compare with the first example, you are basically depending on not crossing the boundaries, but depending on a specific structure that maybe will change in the future, right? And this is real code. So I hope this is clear. So let's move on to dependency management. This is also a super tricky one. Because we try to build, and we have more or less a clear modular architecture, but with time, again, we developed some circular dependencies. And in order to run away from the circular dependency that we created in the first place, we were doing some nasty and ugly hacks. Architectural workarounds is what I mean. and this makes the code base super fragile. So the pains. Circular dependencies with forced to do pretty nasty ugly hacks, and inconsistent patterns. And this is a lack of communication, right? So not everything should be, I don't believe everything should be written and we have a methodology for absolutely everything, but if there are some patterns that keep repeating over and over, it has to be some consensus in a company so big, because thousands or hundreds of developers, it has to be written somewhere. So circular dependencies, ugly hacks, inconsistent patterns across features. So the lessons first. Dependency injection over global access, right? So you don't want to know the technicalities. You just want to be provided with the dependency that you need, and that's all. And consistent patterns team-wide. And this lesson can really, it could be in each of one of these panes, because most of the time we do things because we don't know the official way inside the company of doing it, right? So let me show you one snippet. And this is real code, I have to say you. So this use actions module, let's say, needs tracking, right? But probably tracking also needs the user module. So JavaScript doesn't know how to load because it goes from module A to module B, but module B also needs module A. So circular dependency problem. In order to run away from this, instead of dealing really with the problem and do the changes needed, maybe a shared service, I don't know. There are solutions. You grab for the prototype in this case. And you can grab the router, the tracking, that is a plugin, by the way, so you're injecting in this instance, in the Vue instance. So no import here, no circular dependency problem. That's all. And again, it works. So the system, this is the complicated thing. When you try to come, sorry for the tangent, but when you try to go with these kinds of discourse to a project manager or a stakeholder, they don't understand because they connect to the product and the product works. So good luck saying, no, it's because the product, if the product doesn't work, maybe then they will listen to you. But if it works, they simply don't care, right? So the developers also are more or less being pushed to I'm not trying to justify, right? But this has a reason. And it's not a technical one. That's the point I'm trying to convey, right? So what do we do instead of these early hacks? We can use the provide and inject API of Vue to just in a component, or in this case in main.ts, you are providing some dependencies down the line, and the component that's needed just can inject it and use it. And this is a much more cleaner way than dealing with Vue prototype. And also, you have to establish some patterns. So this becomes a problem, and this maybe is different between each company, right? Maybe you don't have this problem. You have another problem. So someone has to intercept this and create a rule or some kind of agreement or some kind of process in order to stop repeating again. So this was a very nasty one, to be honest. So let's move on. Well, as you can see, you are injecting only what you have provided before. And this is a perfectly clean way of doing it. And it's also, you don't have to use any other dependencies. This is the Vue API, right? Provide and inject. But remember that you have to use the same component tree in order to share this kind of information. You can also use composables. In fact, here we're using a composable and provide and inject, right? So, performance. So with thousands of components, we have some small performance anti-patterns, etc. So you can, let's imagine this scenario. We have a dashboard, and this dashboard has 30 components, 30 plus components, I believe. And only the first 3 are above the fold. So above the viewport, in the viewport, sorry, it's only the first 3. So you don't know if the user is going to scroll down for the other 27 or not, but are being rendered, hydrated with data about the user, and also using some pretty expensive 2D libraries to represent the data graphically and sit there. Even maybe you don't scroll, but it doesn't matter. It will be there. So this was the first sign that we have some bottlenecks in any other, also in other views, but this was the first one. So the pains that we also doing unnecessary deep watchers, and what I was saying, the same as before, what we pushing everything into views as default, we were doing eager loading everything as default. So everything has the same weight and the same impact and the same meaning. So the lessons. Well, first of all, you should implement some kind of observability as soon as possible. You should have to get the data as soon as it happens. You have to be close to what's happening. You shouldn't be notified by a user, by a complaint that something is not working, or is lagging, or the performance is super bad, or suddenly some KPI gets lower and lower and lower. So there are some pretty amazing observability tools. We use Datadog and Sentry. And I don't know if you know, but you can detect the, I don't know how to say it in English, but it's like the frustration of the users, rage clicks. So you can detect when the user starts clicking like super rage because he or she can't find what to do or it doesn't work. So if this happens, you want to be notified as soon as possible, right? So this is outside of any technicality, observability as soon as possible. Then you don't have to do this every time. You don't have to observe a whole object. You can imagine in form what lives inside this form object. Let's imagine a super complicated form, a multi-step form. Yeah, you can imagine that what lurks there. So you can, if you want, observe or react or watch only what you need. And this is in the API, but for some reason, maybe it's more obscure than just doing the watch. But we were doing this a lot, specifically with forms. And the difference was amazing. Was amazing. And also, two techniques, well, not techniques, but two ways of dealing with this eager loading by default problem. The first is implement viewport-based loading. So you can use the intersecting observable API, and you can use, let me use. I don't know if you know this, who here knows this library? Vue.js, right? It's amazing, amazing. So you have this use intersecting observer because we made the mistake of creating this composable by ourselves. So you don't have to reinvent the wheel. You can just pull this off, and it will be probably better built, better tested for sure, and it's ready to use. It's like more or less like a plug and play. So why do you need this composable? Because you can use viewport-based loading. So if you know this API, basically sets a threshold, and if your component or componentry intersects the viewport with a threshold, it will launch an event, and you can react to that event and do whatever you want, right? So in this dashboard example that we were talking, let's imagine that the other 27 components are using this viewport-based loading only if the user is intending to scroll down, and you can put a very generous threshold. So if the viewport is intersecting the threshold, you can load the components. And this at least will alleviate the problem because the components, the 27 components, are not loaded. But they will be part of the bundle, right? And again, they're pretty expensive components. So why are they part of the bundle? Because maybe the user won't scroll, just sees the 3 most important ones and move forward. So what you can do also is not only lazy load, but async load the components. So you can combine, you can use these two techniques independently, but you can combine them. And this is a simple code snippet. This is exactly what we are doing. So we are using this expensive chart. Of course, this name is made up, but this is a super expensive chart. Asynchronously, and we are only loading when the viewport intersects. So when the users scroll down, we are asynchronously load the component and showing it. And this was a massive difference in performance, not only in this dashboard, but in other views. So, and this is, again, you don't need any other dependencies. This is already built. You can use it right away. So, TypeScript integration, and I'm short on time. Okay, I have a hate-love relationship with TypeScript, to be honest. And I try to write it here. TypeScript for me isn't the problem, it's, the shit around it that is difficult to work it. So what do I mean? Libraries without proper TypeScript support again, start zero isn't enough, right? Maybe your own libraries, I have to be honest. And you lack TypeScript support, so you create a shim and you start putting any everywhere, right? Just to reach production, just to cross the mark and say, hey, this is done, we can move forward. And you start with 1 line, 2 lines, 3 lines, 5 lines, 10 lines, and months from now, it's more than 100 lines. And it doesn't make any sense, right? Because you're using any, so you're basically shutting up TypeScript just to move forward. You don't have, it's even worse, right? Because you have a false sensation of achievement of security. So that's what I mean. And also file-by-file migration. Why file-by-file migration? Doesn't make any sense, right? But you are being pushed because you want to reach production again. You see that the technicalities is not the cause, it's the effect of something, right? So lessons, feature by feature, not file by file. So you will have to slow down a bit, and instead of porting a file, you have to port the whole feature, and you will need some kind of consensus, right? And you can, if this happened before, you can go to the project manager or stakeholder and say, hey, look, remember what happened last time, right? Because you will have to invest the time no matter what. And also treat SIMs as a technical debt. So this is what I thinking, right? Icon alert any, icon arrow down any, doesn't make any sense. It's stupid, right? But we were doing this a lot. So what to do? Feature by feature and not file by file. And if you don't have type and you have an in-company UI library, you should ask for proper typing, maybe help the team that is taking care of it. And if you're using other libraries that doesn't have TypeScript support, you can help them or contribute to the Definitely Type initiative, right? But this was a mess. This was a horrible mess. And the last one, right? Composition API, I have 3 minutes. Vue 2.7, promise and a smooth migration. And remember the Vue 3, it's true. It's not, I won't say it's smooth, but the path is already laid out. The reality in our team, we created another monster. Not only the PR monster, but 2-headed monster, because of course, we were using both APIs at the same time. Why? Because it's the path of least resistance, right? So you are using composition API wherever, and suddenly you have to interact with an Options API component. What do? You don't port the component. You just add the setup top, and that's all, right? And this creates a lot of mental overhead. So inconsistent mental models, mixing versus composable, right? You have mixins for the Option API and composables for the composition API. And if you try to port a mixin to a composition API, it's not a straightforward process. You don't have this context and a lot of technicalities, right? So this was hurting us. So the lessons, 1 API per component, and that's all. And if you have to force this with a rule, do it. 1 API per component, and invest in proper training in company. Maybe a workshop, right? Just to make sure that everyone is on the same page. And force, again, we did this for TypeScript, for instance. You cannot create JavaScript files. You can edit a JavaScript file, but you can only create new TypeScript files, and it works. Works like a charm, right? So the same, you create a new Vue component, composition API. You are editing an Options API component, you port it to composition API, because again, you will have to pay no matter what. You can do it in your own terms now, or you can do it later with interest. And this is the example, right? And this is perfectly valid, of course, but in a big code base with more than 100 developers, this is a problem. This is a problem. You cannot think in composition Options API or composition API. You have to think in both at the same time. So think about it. And of course, it's a lot easier just dealing with one mental model, one or another, not both at the same time. So this is the last technical slide. I have 40 seconds. But we have seen the what and the who, right? What happens and how we solved. But what we really learn isn't something technical, to be honest. This is what I mean. All these technical challenges had one thing in common. We kept adding more complexity instead of simplifying it because of the human factor, right? So the real lessons, for me, my humble opinion, is not about Vue or TypeScript. It would be super naive to think, oh, let's fix how we work with TypeScript or with Vue, and suddenly everything will become clearer and prettier, etc. It won't work. It's about how teams or developers or human beings make decisions under pressure. For me, this is the main lesson. So what they mean is this, that it wasn't a technical failure. Why? Because the guys existed, the tools work. What we felt was an alignment in communication, right? So, and the human tendency to always push forward. We saw this in each part, right? We do nasty things because we are being pushed to reach some kind of artificial deadline or goal, or etc. So, last slide. I won't say that you have to do more faster. You have to do just the opposite. Sorry. This is not the last slide. This is the second to last. So the biggest risk in large system is moving too slow. It's refusing to stop. So for me, this is pretty clear now. When I was preparing the talk, it became even clearer, right? We have problems moving too fast. We have problems with technology, but refusing to stop made the Vue 3 migration impossible. TypeScript with themes all over the place, cross boundaries with Vuex and doing some nasty things because we can't stop as a company. Of course, also, we can't stop as a team, and of course, also, we can't stop as an individual. So, and this is my last slide. I won't say that you have to do is move faster and do more. It's just the opposite. Do less, but better. And that's all. Thanks.